Hello everyone, hope you're keeping well and safe in this time of pandemic. Also a very happy new year to all of you. Hope this year is more positive and brings you all a lot of happiness. In this video, we will study long division, the method for finding square roots. For finding square roots, first, what is a square root? Well, a square root, let's assume that we have a certain number, say 3. Now, let us say that we multiply this number by itself. 3 times 3, that of course is 9. Now, so 9 is called as the square of 3. So 3 squared equals 9. Thus, since 9 is the square of 3, it has the additional property that if you take the square root of 9, this is the square root symbol, then it will give 3. So, to find the square root of a number, that the square root of a number is such that if you square the result, then it will be that same number. For example, if you take 16, then 4 squared is 16, since 4 times 4 equals 16. So the square root of 16 is 4, so that's what a square root is. Now normally for small numbers like these, prime factorization is a really good method. However, that's for small numbers. In this video, we'll learn the method for very big numbers, which is long division. So first, let's assume that we have a completely random number. I'm picking this number at random, so it may actually have an irrational square root, but that's okay. For we just want the square root, the real number part of the square root. So let's assume it is 5, 8, 8, 1, 0, 4. First we'll work with even numbers as they are a bit easier. So first, take the number 58. You first have to answer the question, what is the square root of 58? Well, the problem here is that 58 is not a square root. However, we take the smallest number, which is a perfect square. Perfect square is a number which is the square of a real number, for example 3. And the smallest perfect square the largest perfect square that does not go larger than 58. So for this time, it will be 49 because it satisfies both properties. 7 times 7 is 49. So here, thus we will write 7 and here and on the top. 7 will be the first digit of the number. So here we will now for 7 we'll do the calculation and it turns out to be 49. The next step is pretty normal in division, just subtract them. It happens to be 9, so we'll write 9 down. Now bring down this pair of numbers. This is why I've written them as pairs in the first place. You've got to write them as pairs. You have to start from the far right. Where's this left? Whatever. Yeah, this is left. So far left, and you have to make a pair out of those two numbers. Then you have to go to the next two, and then after that. Okay. This will be important later on when we discuss the ones with an odd number of digits. So now we will write 81. Here, we'll bring it down. If you want, we can write the arrows, and in fact I will. There, now it should be more clear. And now, meanwhile, see this number 7? Whatever digits are added in the divisor, we will double them. For example, 7's being added to the divisor, so it will become 14. And however, obviously 14 will be too small, so we'll add a second digit. This happens all the time, so actually in this case it's the third digit of the divisor. So this is how it works. We have to think of some number that will go both in this spot and here, such that when we multiply it by the divisor, it will form the number which is closest, the largest number closest to this that does not go over it. Now this is basically trial and error. So let's assume that the number is say 6. So here how will it work? Well, let's assume that it is 6. Well, we will do the calculation of about 146 times 6, and we'll check if it's bigger or smaller than 881. So 6 times 6 is 36, and 4 times 6 is 24. 24 plus 3 is 27, and finally 6 times 1 is 6, so 6 plus 2 is 8, so 876. However, let's just check if it is if it can get bigger. So let us compute 147 times 7. Remember, both this digit and this digit are going to be the same number here. So let's do the calculation. So 7 times 7 is 49. 7 times 4 equals 28. 28 plus 4 equals 32. And then 7 times 1 equals 7 plus 3 equals 10. 1029. Now obviously 1029 is too big. It is larger than 981. Thus we'll go with 876, and actually here 6 here and 6 here. And now we are going to write 876. And now again we will subtract. This will be regular. For example, 81 minus 76 is 5. 9 minus 8 is 1 and 0. You can check this for yourself, but yeah. So the answer is 105. Finally, we will put a 0 for here. Now here the digit added was 6. Okay, this was the digit added. Remember that. Okay. So we will double it, not the entire number. So, and whatever it is, it will be added to the number. So we'll first separate it from the number. For example, 146, we'll take it as 140 plus 6. Then we'll double this digit, this 6. It becomes 12, and then we add them back. This gives 152. However, this won't remain the divisor. Now here, this digit, now we have to do the same process except for this number. At this point, we just repeat the multiplication stuff. So, fine. Okay. Yeah. So now we have to try out these numbers. So let us assume that we choose say 6 again. So then it will be 1526. Remember, you always add it, but don't write it immediately because it may be wrong, and then yeah, bad stuff will be happening. And then you will do the 6, and then 6 times 6 equals 36, and then 2 times 6 equals 12 plus 3 is 15, and 5 times 6 is 30 plus 1 is 31. And 1 times 6 equals 6 plus 1 plus 3 equals 9. So 9156. That is small, however, it works. However, because remember, this number is 1,000. And it's obvious that if you add 1,000 to this, you will already be very close, but then that'd still be the 526, and it will get higher. If you want, I'll also do 47. So 1527. times 7. 7 times 7 is 49. 2 times 7 equals 14. Plus the 4 is equal to 18. 5 times 7 is 35. Plus the 1 is 36. And finally, 1 times 7 equals 7. Plus 3 equals 10. And sure enough, 1069, it's too big. So 9154. Also, I'm going to draw the arrow for convenience, for your convenience. And of course, we will write the 6 over here and the 6 over here. Now, if you're choosing a perfect square, keep in mind that if you're choosing a perfect square, then these two numbers would be identical. However, since I picked a number at completely random, there was a very high likelihood that it would end up being a non-perfect square, like what happened here. However, I suggest that you just also pick numbers randomly. However, after that, you check the answer with a phone. Just divide. There's a square root option on the phone calculator for you to check. And anyways, now we'll just subtract. So here for you guys, I'm just gonna do it showing this test. So here, this is just regular subtraction. Now, this method mostly involves normal arithmetic, the type you learn early on. So now 4 minus 6, obviously 4 is too small, but 0 you can't borrow from it, so 5 will become a 4. Now 0 becomes 10, however, it will get crossed to become a 9, we need to borrow from it. Thus 4 will become 14. So 14 minus 6 is 8, 9 minus 5 is 4, 4 minus 1 is 3, and then 10 minus 9 is 1. It's pretty obvious. And finally, we have 1,348. However, this time, we don't care about the remainder. If it is 0, that means it's a perfect square. So here it isn't, so it's not a non-perfect square. But what we are really interested about is this number, 766. That is the square root, or in this case, the approximate square root. You can go even further however, if you're going to want to do decimal things, then you will have to make pairs away from the decimal point. In fact, just place the decimal point for convenience so that you can remember, always make the pairs away from the decimal point. For the integers, it's this direction, and for decimal places, it's this direction. And now, finally, let's tackle the problem of odd numbers which have an odd number of digits. So this time, here the pairing is actually a bit different. Remember, well, let's assume that point is here. So here, let's assume we have a set. It is going to be wait, let me just write it. Okay, so I've written the number and I've given this decimal point so that you know that to make pairs in this direction. So here there's a 5, 3, 9, 5, 6, and 2, 7. Those are the pairs. Now, so here first we are going to have to figure out the square root of 5. That's going to be 2 and 2. The square root of 4 is 2. So here it will be 4. Here it's obvious 1. And now we're just going to make it 139. Now, of course, we're going to double it this time since 2 is relatively small. This will only become 4. Okay, we always double it. And now, we're going to have the biggest number, which when we put it here and also put it here, when we multiply them, it results in a number that's about here. That is closest to it. This is the largest number that doesn't get over it. So here, let's assume we try 3. So that would mean 43 times 3. So here 3 times 3 is 9, and then 4 times 3 equals 12. So 129. So we're going to place a 3 here, a 3 here, and it will be 129. Subtract and you'll get 10. Now we're gonna put 56 here. So now the number is 5056. Again, we double this digit. We treat it this time as 40 plus 3, and then we're gonna double this 3 to a 6 and add them back, and we got 46. And here we're gonna again place the digit here so that it covers all the properties. So this time, let us assume it is 2. So this time it will be 462 times 2. So it will be 4 here. And then 2 times 6 equals 12. 4 times 2 equals 8. 8 plus 1 equals 9. And 924. Which obviously, if it were any bigger, then it would get bigger, because 400 plus 924, you can use estimations here. Since 400 is pretty close to 462, so if you add 400 to 924, it will already be far bigger, I think in the 1300s. So you can safely conclude that it will be 2. So, and to here, so here it will be 924, and now 6 minus 4 equals 2, 3, and then 1. Okay, so 132, and finally, so now we'll finally, also let me draw you. We're going to deal with the final pair, 27. So here, again, that's the same process. This time we'll double 2 again. So it will be 464. And this final one, well, again, let's assume it is 3, because it's pretty similar to this. However, we may be wrong, okay? Wait a second. So 4643 and times 3. So 3 times 9 equals 9. Sorry, 3 times 3 equals 9. 3 times 4 equals 12. 3 times 6 equals 18. Plus 1 equals 19. And finally, 4 times 3 equals 12 plus 1 equals 13. However, here we arrive at the conclusion that 3 is far too big, so we can't use 3, so we'll have to instead use 2. So it's pretty close, actually it's pretty far. Okay, so 4642, this is why you don't immediately write, oh, this is 3 and this will be 3, and then I work it out, because then you may realize that it is wrong. Here I'm using the sketch pen, so I can use, sorry, not sketch pen, but I'm using the marker so I can erase it. However, just don't do it, especially if you're using pen. So, and then 2 times 2 equals 4, and then 2 times 4 equals 8, 2 times 6 equals 12, and 2 times 4 equals 8 plus 1, 9. So 9284. And now we're just going to do subtraction. And this time again, I'm just writing it down. So it will be 13,227 minus 9284. Okay, so first 7 minus 4 is 3. 2 minus 8, well, 2 it is smaller than 8, so we'll have to borrow from 2. This becomes 1, and then 2 becomes 12, and then 12 minus 8 equals 4. Now this is 1, but 1 is too small for 2. So 3 will become 2, and then so that this could become 11. So 11 minus 2 is 9, but then again 2 is too small, smaller than 9, so 1 becomes 0, so that this becomes 12. So 12 minus 9 equals 3. So the answer is 3,943. Of course, we don't really care about the remainder. We're just adding it in. and it will be important if there are other later steps. However, now that we have finished, we don't care about the remainder. We just care about the answer, which is 2322. So you can say that the square root of 5,000,003. Wait, let me add. Yeah, and also the commas don't interrupt the pairs. For example, this 5, 6, which has the comma in it, just ignore the comma if it's coming to pairs. However, I'm adding it in so that you understand what number this is. So this is 5,395,627. The square root of it is approximately 2,322. So that is the method for long division. So